Hi everybody. So in this video we're going to look at simplifying expressions using the rules of indices. In our first example we're going to cover the multiplication and the division rules. So for example A, we've got 2 to the power of 3 multiplied by 2 to the power of 4. We know 2 cubed can be written as 2 multiplied by itself 3 times, and 2 to the power of 4 can be written as 2 multiplied by itself 4 times. So we could write this as a single power of 2 because we've got 2 multiplied by itself 7 times. But what the multiplication rule tells us is that all we need to do, because these bases for base of 2 are the same, we can just add these powers together. And you can see that 2 to the power of a 3 plus the 4 does make 2 to the power of 7. Okay? So for question B, the bases are the same, we're multiplying them together, so we can just add these two powers. And when you add the 7 and the negative 4, we get 2 to the 7 take away 4, which is 2 to the 3. And then for question C, if we have 2 to the 11 divided by 2 to the 5, well, I can write this as a fraction in expanded form. And then you can see that this 2 will cancel with this one, and we can continue cancelling out the 2's on the denominator. So we've taken away 2 to the power of 5. And this is called the division rule, where because we have the same base, and we're dividing the exponents, we can just subtract these powers. So this becomes 2 to the power of 11 minus the 5, which is 2 to the 6. And then for part D, we can add these two powers together using a multiplication rule. So we get 2 to the power of 6 add 4, divided by 2 to the negative 8. So our numerator becomes 2 to the 10. And then we can use the division rule with our denominator. So we'll take away the negative 8. And when you take away a negative, we get a positive. So this becomes 2 to the 10 plus 8, 2 to the 18. And then for question E, well, this 2 is 2 to the 1. We can add these two powers together using a multiplication rule. So we get 2 to the 4. And then using the division rule, we'll have a 1 take away the 4. And we get 2 to the negative 3. Okay? Let's try example 2. So in example 2, we're going to combine the multiplication rule and the division rule with the power rule. And I'll explain what this means. If we look at example A, we've got a squared cubed, so we're multiplying this by itself 3 times. And then, using the multiplication rule, we would add this 3 lots of 2 together. But we can write this as a to the power of 3 times 2. And it is when you multiply these two powers together, so the 2 and the 3, that gives us the power rule. So this will just be a to the 6. So if this is a to the 6, we can use the multiplication rule with this negative 5. We get a to the 6 minus 5, which is just a to the 1, or a. Part B, using a power rule, we would multiply these two together. This would give us b to the 15, divided by b to the 6. And then using the division rule, we'll have 15 take away 6, b to the 9. For part C, now all we need to do with this expression is we need to apply the power rule to each of these 3 terms. So we'll have 4 squared, w squared, squared, and then y cubed squared. So this is very similar to expanding out a pair of brackets. Then we can work out each of these separately, and we get 16 w to the 4, y to the 6. And then for question D, the first thing I'm going to do is expand out this denominator. So I've got m to the power of 2 and k squared to the power of 2. And then we can divide the 12 by the 6, and we can simplify this power. And now we can apply the division rule to the n to the 4 over m squared and k to the 9 over k to the 4. So we get 2m squared times k to the 5. Okay? And then for question E, we'll expand out this bracket with the x, we'll expand out this bracket with a y, and then to simplify this, I'm going to put the a terms together and the b terms together. So now you can see we can use the multiplication rule and add the powers of x and y for our base of a and separately for the base of b. So we've got a to the power of x plus y multiplied by b to the power of the same x plus y. Okay? So I hope that's given you an idea on how we use the multiplication, division and power rule. So now we're going to look at a couple of exam style questions. So perhaps you want to try this question yourself. You can pause the video and when you come back, we'll go through the work solution. Okay, so welcome back if you had a go. So for question A, you can see we're going to use the multiplication rule to add these two powers together. So we've got 5 to the power of 4 plus 8, which gives us 5 to the power of 12. Part 2, we'll use the division rule, where we've got the 8 take away the negative 10. When you take away negative, we get a positive. So we get 9 to the power of 8 plus 10, which is 9 to the 18. And then for part B, we'll add these two powers together. And then we need to use the division rule with this 13 and the n. So 3 to the 13 minus n is equal to 3 to the 4. And now we can just equate these two powers. So 13 minus n must equal 4, n must equal 9. Okay? Let's try one more exam question. So again, perhaps you want to try this question yourself. You can pause the video, and when you come back, we'll go through the work solution. Okay, so welcome back if you had a go. So using the power rule, we'll expand out this bracket, so we've got 4 to the 3 and y squared to the 3. 4 cubed will give us 64. And then we'll just multiply these two powers together, and we get y to the 6. Part 2, we can do the 3 divided by the 6 to give us 1/2. We've got x to the 1 divided by x squared. So we'll subtract the powers and we'll get x to the negative 1. And then we've got y to the 3 divided by y to the 1. Again, subtracting these powers, we get y squared. And then for part C, we'll use the multiplication rule with our numerator. So we get w to the 5 plus n. And then, using the division rule, we'll subtract the 3 from the 5 plus n. We can tidy up this power, and then we can equate the powers. So n must equal 8. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson from my website, mrmathematics.com. I'll leave a link in the description below.